Hello and welcome to a Unity tutorial. Today we're going to be creating a water shader. It's going to be a very basic water shader using two perlin noise or cloud textures. And the key to this is we have two textures at random offsets, and we'll be taking the difference between them. And it winds up producing these distinct peaks that kind of blend and morph into one another. And it just reminds me a lot of the way that peaks of water interact. And it's very simple. So this is the basic principle, and we're going to be using this to create a water shader for our pogo stick in our game Pogo Panda. So we'll create a standard surface shader. As per usual, we'll create the material. And we'll set this material in-game to our shop so that we can actually see it in action. We'll apply it to our prefab. And just as a reminder, I have a tutorial on creating an in-game shop if you're more curious about how that stuff works. So just to make sure we're hooked in right, we'll mess with the base color and make sure it changes in-game. Looks good. So how do we create these textures, these noise textures, to be suitable for the game? Well, there's two parts to this. The first is I want these to be repeatable or tiling textures, and the other we'll get to in just a second. So a quick tip to make tiling textures is just taking the same texture and reflecting it in each of the four corners. So we're going to copy, create a new layer, and then flip vertical here, copy, create a new layer, and flip horizontal here. And voila, we have a repeating texture just by reflecting and repeating, basically. So the other technique we're going to do is instead of using two separate textures, we're going to flatten these into a single texture. Because we only have a single channel of data, basically white to black, we can turn that into red, green, or blue, and then flatten them down later. So we'll set the red layer here to multiply, and then we have a texture that uses only red and black. Likewise, we'll create a layer fill to green, multiply that, and then we have a texture that's only green and black. So what we can do is add these together. The black values will sum out to 0, and the red and green channels will store their respective the noise data, basically, for each channel. So now with a single texture, we have, note that this will be repeating and or seamless. It will look a little funky. It looks a little bit more symmetric than you would expect, but usually you can get around that. So in the shader, we're just going to test the basics here by sampling the red and the green from the same texture. So we're just going to start modifying some of the default behavior and setting the red, green, and blue to a modification of white. So basically, or the base color rather. And we're just going to multiply that by the difference between the C.R and C.G, which is the red and green channels of our noise texture. And so now we have a very black and white texture, but this is going to be very static. And remember, we want these waves to be animated, which means that our layers need to be able to move independently. And in short, we're going to need to sample our texture twice, once for the red, once for the green. And each of them we're going to need to offset the UVs. And that's rather easy. We just add a vector 2 to our in.uv main text. And we're going to use the time variable, the underscore time that Unity provides, so we don't have to mess with the scrolling and controlling that via a script. The fact that our texture mode is set to repeat which it is by default, so don't worry about that. Means that we can just continuously increase the time and we'll get a scrolling effect. So for our red, we're modifying our UVs by positive time.x, and for our green, we'll do negative time. So the two kind of intersect. And now at this point, we don't really have use for that C variable anymore, so we can actually just set the albedo directly. At this point, I'm still kind of learning the basics of Vim, so I occasionally miscopy or misdelete. But I do enjoy working with it all together, again, due to its simplicity. So once we've removed that C, it looks the same in the preview, but once we hit play, and that time variable starts to take effect, we'll start to see a little bit of rippling, a little bit of motion happening. But it does look rather dark, and we're not really seeing those peaks we're looking for. So at this point, I'm going to try changing the tiling to kind of get a zoom in. And this is why our texture doesn't really need to be repeatable, but in your case it might. So when we set the color to blue, we start to see like reddish orange in our material, and that's an indicator that we're multiplying by a negative value. And we don't really want that. We want all these to be positive color values, just to keep everything in the same space. So we'll take the absolute value of the difference. And no more reddish orange. In fact, now we're starting to see the peaks that we're looking for. And it's kind of starting to have that flowy water look to it. So this is good, but I'm not quite ready to throw in the towel yet. So I'm trying 1 minus the absolute value, just kind of playing around, seeing what happens if the base color is darker and our peaks are a little lighter. I'm trying another technique now, which is using the lerp function. So we'll lerp from our base color to white, and we'll use our factor as the lerp time value. And now we have white peaks, light blue and white. And this looks pretty good, but it's sort of actually hard to make out, especially in the game view where we have this pixelated effect. So in order to accentuate those high values, we can use a quadratic function. In other words, power this to the power of 2. So that way values that are in the halfway, like 0.5, are going to get reduced to like 0.25, and the values that are really close to 1 will stay close to 1. And now our peaks are starting to get a little sharper. In fact, I think this is sufficient for our needs here. So we'll call this done, and we'll just have a closer look. At this point, I'm always really examining the shader to see if there's anything else we can do, any last little tweaks. But I'm really happy with the way these noise textures overlap to produce the peaks. So we'll just try changing the color a little bit. That looks a little too much like clouds in the sky. So we don't want it to be super light or else we can't see it. And in the future, I might use this to create like the refraction shading that you sometimes see, like the reflection of water onto other surfaces. But for now, I hope you learned something about textures and shaders. Maybe you can create your own water shader. Thanks for watching.